Hey guys, eventually I'll run out of filament for the Tiko, so I thought while I still had filament I would go ahead and design a full filament spool jig so that we could use it to take filament from larger rolls, like your standard size 1 kilo rolls that you'd buy like Hatchbox or LD or eSun, BAMTech, whoever, and set those up so that you could put the Tiko spool on a drill with some 1/2 inch all thread, and that would allow you to spool the filament without having to do it by hand. So that's kind of the project. The measurement that I got for the diameter was anywhere from like 2.56 inches to 2.6, a little bit over. You can kind of see here that the Tiko spool, the center hole isn't quite 100%, but I figure I would kind of go through the process, or at least my process. I'm by no means an expert on Fusion. Just kind of picked it up because I'll be doing a CNC lathe project, and these turning tool paths will be really helpful. But yeah, so that's the project for the day. There's probably going to be a way better way to go about doing some of this. As I mentioned, I'm no expert at Fusion by any means. I've worked a bit with other CAD softwares, and Fusion's not bad, at least for what I need it for. So if you have any questions, or if there's a better way to do it, definitely put it in the comments. Some of the shortcuts are just C for circle. That'll give you a circle, escape to back out. I like keyboard shortcuts just because they make things a lot easier. To change like this, now that I have this in place, it looks a little bit small, so you just double click it and then type in your new dimension. Most of this is probably pretty basic for anybody that's used CAD software. Q for press pull, and I don't want this being extremely thick because it's just a waste of filament. There's not going to really be too terribly structural. And now that I said that, I need to add another circle for the inside diameter. The plan is to make this the bottom piece that's going to fit through the spool. So then, with that being 2.53, I don't know, 2.125 will probably be okay. And then I looked up the spec on the all thread, and because it's cheap, I mean, you can get all thread from like Lowe's, Home Depot, kind of whatever you have around you. And the spec was 1/2 inch nominal, so that's what I'm going to use. You may, actually I'm going to do 5.2 for filament shrinkage, so then I can remove, I could probably get rid of this guy right here. Just trying to reduce the amount of filament that's used. So I'm going to do L for line. Do something like that. Got quite a few lines going around, so it's getting kind of clustered. And then probably somewhere around there. This will make more sense here in a minute. Okay. 3.5 there. 2.125 there. 2.53. Okay. Oops. So do Q, pull this up, I don't know, 0.25 will probably be sufficient enough. And then we'll add the sketch back in. And then we're gonna bring this. It's 0.26, so this is should be the 1/2 inch circle. So we'll do Q, press pull, and then we'll select. No, that's not right. So I actually need to add another circle here to thicken this this hole, because if I go ahead and extrude it, well, I don't know, that might actually work. So if we do 3. I use the caliper to get that dimension. Yeah, something like that would probably work, because we don't need a whole lot of strength, I guess you could say. But I'm going to go ahead and go back in and add another circle around here, just to make sure it's the right size. D for dimension, which that's fine, that just means that it's a reference dimension and not an editable one. And then we'll hit C for circle, and then we'll make this it's 0.52, I don't know, 0.66 will probably be good. So then we'll go ahead and come back out, stop the sketch. Whoops. And we'll come back in here. I don't want it so weak that it breaks. And then we can do join distance to, just so I don't have to exit out, and then just click the top face here. And then that way we're not wasting as much filament. It's still quite a bit of waste, just for what it's going to do. And then we can use a washer here. Flat fender washers are pretty cheap. So 1.265. That gives me 2.53. So we'll call that one good. So go ahead and save that. Let's create a new folder. Let's see, Tiko Filament Spool. I usually name them like this, so it's a little bit easier to keep track of. So then we're going to duplicate this. So to copy a sketch, and this is kind of a pain, and I usually mess it up, but let's go ahead and so we're going to do a new design. And then I'm going to edit the sketch again, because I don't want to have to sit there and redraw this over again, and it's not that difficult, but it does take time. So then you can, supposedly you're supposed to be able to copy. So if you click out here, I haven't had much luck, but if you click right here in the center and copy, and then you can come over to this drawing. Make sure the units are an inch, or for the sketch at least. We'll do origin, Z, whoops. So I'll just do sketch there, hit escape, right click. I think they just had an update, because I was having some troubles with this a few days ago when I was doing the Tiko, or the TIAO smart sprinkler controller. I needed to copy some stuff. But so I don't really care about where it's placed. But so the sketch is there, so then Q, press pull. This was the issue I was running into. So I'm going to go ahead and stop sketch. Then we'll go ahead and select everything we need. And then we'll make this, I don't know, 0.25 will probably be good enough. And then I think on this one, we'll do a recess. I don't think we really need it. I was thinking just a slight recess, probably 0.1, whoops, -0.1, and that just gives somewhere for the washer on the top to seat, because then you'll have a nut that you want to put up here. But I think I might make this a little bit thicker. Let's see, it's 0.25, so we'll make it 3/8, so 0.375. Or you can do 3 divided by 8, and then that'll give you your 3.75. I won't list it, but it's 3.75. Oops. And then I'll go ahead and save that, and then we can stop sketch here, get rid of that. And we can do new design, and then we'll drag this in. Whoops. Oh. Good. So now you have to save the design first before it lets you add components to it. And then I like to go ahead and ground this so you can't move it. It seems to make things a little bit easier when you're trying to build out mates. And we need to change this. Okay, so we'll drag that back in. I'm in the US, so primarily we do everything in inches. I was doing a project, or helping a guy with a project, and he wanted everything in millimeters, which is fine. I usually just work in inches. All my models are in inches, and then I let the software handle everything else as far as the conversion process goes. So then we can do click there, and then if you hold Control, click there, and then hit J for joint. Might actually want to cancel that, and then we'll do a joint on this face and a rigid joints. Okay, in this one. I guess we could do revolute. I'm not sure why that's doing that. So do that. We'll see if I can not sure why I put the point there, but I guess it doesn't matter. So I'm gonna click there and there. Yes. That's still gonna make me do the one sec. There it goes. So if you click the edge is what it wanted to get the joint that I wanted. And I haven't built really big components or assemblies in Fusion yet. I just haven't had the time. But yeah, this should, in theory, work for rewinding the filament spool that came with the Tiko. I did already print an external filament spool holder, and I think for some reason octave filament comes on a small spool. But I'm going to give this a print. I don't know if it's all going to be printed on the Tiko, but I'll probably print this lower piece just to see how it goes, and then print the, well, we'll see how that goes. If the lower piece prints well, then I'll print the entire assembly on the Tiko. But and then if I'll test it, and if it works, I'll publish the model on Thingiverse. But anyways, thanks for watching.